A honeypot or deception control is useful because legitimate users should not interact with it. If someone scans it, logs in, opens the fake file, or uses the decoy credential, the signal is unusually strong. But deception is not magic prevention. Security X level thinking asks where the decoy fits, what attack path it observes, how it is isolated, and what the SOC does when it fires. A honeypot is a decoy system or service designed to look interesting enough for an attacker to touch. It may emulate a server, database, admin panel, SSH service, or application workflow. The defensive value is telemetry what was attempted, from where, with what account, and in what sequence. A production architecture should treat the honeypot as an instrumented sensor, not as a real business asset. Modern deception technology goes beyond a single decoy host. Honey tokens can be fake records, documents, API keys, database entries, or cloud objects that should never be used. Decoy credentials can reveal credential theft or lateral movement. Breadcrumbs can guide an intruder toward monitored dead ends. The goal is to make unauthorized exploration observable before damage spreads. Placement is the architecture decision. A decoy in the wrong place produces little value, and a decoy with weak isolation can create unnecessary risk. Place deception near likely attacker paths. Identity stores, admin networks, sensitive data zones, cloud control planes, or lateral movement routes. Then map every decoy to a response action. If nobody owns the alert, the trap is just decoration. A good deception alert should have low expected business noise. A normal employee should not log into a fake admin portal. A real application should not use a decoy credential. A backup job should not open a honey token file. That is why deception can create high signal alerts. Still, senior teams correlate source host, identity, previous telemetry, asset criticality, and containment risk before taking disruptive action. The safety boundary matters. A high interaction honeypot that allows realistic behavior may generate richer telemetry, but it also needs stricter isolation. Limit outbound access, prevent pivot paths into production, monitor changes, and reset the environment when needed. For SecurityX, the design trade-off is fidelity versus risk. More realism can improve intelligence, but it raises operational responsibility. Deception is only valuable if the alert lands in a workflow people trust. Route events into the CM or security data platform. Enrich them with identity, endpoint, network, and asset context. Decide when SOAR automation should contain a host. Disable a credential, or simply open an investigation. The playbook must exist before the trap catches something important. Deception also has governance implications. Teams should document the purpose of each decoy, who owns it, what data it captures, and how long that data is retained. Legal and privacy teams may need to review banners, monitoring scope, and jurisdictional issues. Stale deception is dangerous. It can create noise, unmanaged exposure, or confusion during incidents. Treat decoys like controlled security assets. Consider an enterprise scenario. A cloud team plants a fake admin credential in a controlled test repository, clearly outside any production workflow. The credential cannot access real resources, but any attempt to use it triggers an alert. When the alert fires, the SOC correlates the repository access, identity, endpoint, source IP, and recent command activity. The security architect cares about the full chain, safe decoy, isolated permissions, reliable telemetry, and a tested playbook. Pause here and choose the best design. A security team wants deception in a segmented enterprise. Which option creates useful detection without adding unnecessary risk? The reveal comes next. The strongest answer is B. Deception should be isolated, placed on likely attack paths, and connected to playbooks. Exposing a vulnerable host on the internet is unsafe. Honeypots do not replace segmentation and monitoring, and waiting until a real system is touched wastes the value of early deception signal. The final takeaway is this: use deception as a managed sensor network. Decoys, honey tokens, and fake credentials can reveal attacker movement earlier than ordinary alerts, but only when they are safely isolated, deliberately placed, integrated with SOC workflow, and governed over time. The SecurityX mindset is not, should we have a honeypot? It is, what path are we trying to observe? What risk does the decoy introduce? And what decision will the alert drive?